In 2013, a USA Navy admiral stood before Special Operations Command and made a promise. We're going to build a suit that makes our operators bulletproof, superhumanly strong, and able to see through walls. The Tactical Assault Light Operator suit TALOS was supposed to be operational by 2018. It would stop rifle rounds across 60% of the body instead of just 18%. It would use an exoskeleton to carry the weight so operators felt nothing. Integrated displays would show real-time battlefield data. A cooling system would regulate body temperature. Power armor. Real Iron Man technology. Not science fiction, military fact. By 2019, the program was dead. $80 million spent, multiple prototypes built, and the final verdict? The suit was too heavy, consumed too much power, and wasn't suitable for close combat. But the real story isn't that TALOS failed. It's why it failed, and what quietly survived. So what actually works? What failed? And what's protecting soldiers right now? The core breakthrough from TALOS was the armor itself. Traditional body armor protects about 18 to 19% of the operator's body, essentially the vital organs covered by front and back plates. Revision Military's kinetic operations suit, developed for the TALOS program, achieves 60% coverage. Hard ballistic plates capable of stopping rifle rounds now protect its shoulders, obliques, forearms, and groin areas, previously left vulnerable. The armor used lightweight polyethylene, same material in cutting boards and milk jugs, just engineered at the molecular level. According to SOCOM testing, this new armor covered 44% of the operator's body compared to 19% with existing systems, and weighed 3 pounds less than current loadouts despite the additional protection. How does 3 pounds less weight provide more than double the coverage? The answer is material science. Modern body armor uses ceramic-composite hybrid systems. A hard ceramic strike face, typically aluminum oxide, silicon carbide or boron carbide, shatters incoming bullets. Behind that, an ultra-high molecular weight polyethylene backer absorbs the massive kinetic energy and catches fragments, preventing penetration and minimizing backface deformation. Ceramic is harder than sapphire. Boron carbide is the third hardest substance known after diamond and cubic boron nitride. When a bullet hits at 2,780 feet per second, the velocity of a 7.62 NATO round, the ceramic fractures across its strike face, dissipating energy. The polyethylene backing flexes, absorbing what's left. The bullet stops. The wearer survives. Level 4 ceramic plates can defeat 30 caliber armor-piercing rounds. These are nothing gen threats. These are rifle rounds designed to penetrate hardened steel, and ceramic defeats them at under 4 pounds per plate. Compare that to steel armor weighing 8 to 9 pounds per plate. The weight difference matters because soldiers don't just wear front and back plates. They carry ammunition, weapons, water, communications equipment, medical supplies. Every pound adds up. TALOS aimed to solve this with an exoskeleton, but the armor itself evolved to weigh less while protecting more. But stopping bullets is only half the problem, because lighter armor alone doesn't turn a human into a weapon. For that, you need to see what they can. TALOS wasn't just armor. It was supposed to integrate displays and sensors that gave operators superhuman awareness. The full vision never materialized in one suit, but the components work independently. Enhanced night vision, goggle binocular, System Z, ENVG-B fuse white phosphor image, intensification with thermal imaging. Operator C in complete darkness, through smoke, through fog. Thermal signatures appear as orange overlays on intensified images. Someone hiding behind a wall, their heat signature bleeds through. A weapon aimed around a corner. The sight's thermal reticle transmits wirelessly into the goggles, allowing accurate fire without shouldering the weapon or exposing your body. Over 10,000 ENVG-B systems have been issued to U.S. combat brigades. Ukrainian Special Operations Forces used them in 2024 and 2025 against Russian forces in urban warfare where smoke and rubble made standard vision worthless. The Integrated Visual Augmentation System, IVAS, takes it further. Microsoft won contracts to deliver 280 IVA systems in 2024, with Endurol Industries assuming production oversight in 2025. IVAS combines day-night vision with augmented reality, compass headings, waypoints, friendly force locations, and enemy positions appear directly in the operator's field of view. Health monitoring tracks heart rate, temperature, hydration. AI algorithms process sensor feeds from drones, satellites, and ground vehicles, automatically highlighting threats and suggesting engagement priorities. When connected to joint all-domain command and control networks, what one operator sees, every platform shares. An F-35 spots a radar site, that data appears in the operator's goggles, on the destroyer's combat system, and in the artillery battery's fire control computers simultaneously. The system was supposed to integrate into TALOS as a helmet-mounted display. Instead, it became a standalone capability that's already operational. But vision and armor still leave you vulnerable to something TALOS never adequately solved. The exoskeleton was supposed to be TALOS's foundation. Motorized actuators on each leg would detect movement and assist, transferring armor weight through a rigid spine down to a waist belt. Operators could carry 60% more armor and still accomplish tasks at the same speed as without it. Revision Military demonstrated this in 2015. The suit featured a powered lower body exoskeleton with actuators that picked your leg up and moved it for you. A small power pack and cooling system worn on the back powered the suit and pumped water through 3 yards of tubing to regulate core temperature. The suit went through live fire testing with Special Operations Forces. Operators wearing 60% more armor accomplished the same tasks in the same time frame as operators in standard kit. So why isn't every operator wearing one? Power consumption. The suit required constant electrical input to operate the cooling system, displays, communications, gear, and health monitoring sensors. Batteries couldn't provide enough energy for extended operations. SOCOM called on scientists to develop reliable portable power sources. They failed. General Atomics proposed a hybrid electric power unit, an internal combustion engine that fits in the palm of your hand running at 10,000 RPM. The problem, it was extremely noisy. Stealth is critical for special operations. A screaming engine announces your position to every enemy within hearing range. SOCOM officials stated the final TALOS prototype wasn't suitable for operations in close combat environments due to weight and power consumption issues. The fully integrated suit required 12 kilowatts for 12 hours while weighing under 400 pounds. Impossible with current battery technology. But here's what did work. Unpowered exoskeletons. These don't use motors. They use springs, levers, and mechanical advantage to redistribute weight from shoulders and lower back onto the hips and legs. The body's strongest structures. Soldiers reported running 4-minute miles wearing unpowered exoskeletons when they couldn't manage that pace without them. These systems are in operational use right now because they don't need power. But even unpowered systems can't solve the fundamental challenge that killed TALOS. Integrating dozens of systems into one functional suit proved impossible. TALOS required coordination between exoskeleton mechanics, ballistic armor, thermal management, power distribution, communications, hardware, display systems, weapon integration, and physiological monitoring. All of it had to work together seamlessly under combat stress. According to military analysts, the Center for New American Security concluded current battery technology cannot generate sufficient power to carry the intense load required by the TALOS concept. Covering a user in hard armor for extended infantry operations. The exoskeleton itself proved impossible to design to SOCOM specifications because of the amount of interoperability needed between it and all other necessary suit components. 40 separate joints, 14 powered, all coordinating perfectly, while an operator moves, shoots, takes cover, and engages enemies. The system's engineering challenge was insurmountable. With 2013 technology, early prototypes weighed 600 to 700 pounds. At that weight, an operator couldn't climb stairs, clear a doorway, or move through a hallway under fire. Even after refinements, the Mark V prototype was too heavy for operators to move naturally in close quarters. SOCOM spokesman, Navy Lieutenant Philip Chitty, stated the final prototype wasn't suitable for operations in a close combat environment. The allocated funding, around $80 million over the project's life, was considered low for a project of such ambition. Previous efforts like Land Warrior consumed similar resources without producing deployable systems. Science and technology officials believed core technologies wouldn't be achievable before 2026. By February 2019, SOCOM officially announced the TALOS supersuit concept as originally envisaged was not feasible. But the program's most significant contribution was accelerating development of components that could be issued individually to enhance troop effectiveness. Each piece worked. The complete system didn't. And that's actually better for soldiers in the field right now. So what pieces are they actually using? Every one of these systems exists because TALOS failed. Items developed or matured under TALOS that transitioned to operational use include the lightweight polyethylene armor, now standard issue for special operations units. Small individual SATCOM antennas that allow direct satellite communication without large backpack radios. Unpowered load-bearing exoskeletons that improve weight distribution during long patrols. Powered cooling vests that sustain body temperature in extreme environments. Advanced night vision systems like ENVG-B, fielded to over 10,000 soldiers. Three-dimensional audio systems that help operators locate threats by sound. Non-lethal weapons matured through TALOS testing. More compact communications gear that reduces bulk. The U.S. Army is integrating Iron Fist active protection systems onto Bradley fighting vehicles at a cost of $191 million, with trophy systems being added to M1 Abrams tanks. These systems, developed alongside TALOS, use radar and electro-optical sensors to detect incoming threats and launch countermeasures in European forces followed. Germany's Leopard 2A8 includes Trophy as baseline equipment. The UK's Challenger 3 will receive Trophy by 2027. Israel, having fought extensive drone warfare against Hamas and Hezbollah, upgraded both Trophy and Iron Fist to intercept vertical attacks from drones targeting the vulnerable turret roofs of armored vehicles. The body armor market is projected to grow substantially through 2035, driven by military modernization programs and increasing defense budgets. Defense and security personnel account for approximately 52% of global market share in 2025. Systems are being upgraded with ceramic-composite plates, titanium reinforcements, and modular configurations that enhance protection without sacrificing maneuverability. China's Made in China 2025 initiative promotes domestic development of ballistic-resistant composites and modular armor systems. Key contractors supply armor for the People's Liberation Army and paramilitary police. Russia continues developing exoskeleton programs, though details remain classified. Japan's self-defense forces and National Police Agency prioritize modern, lightweight protective equipment, relying on aramid fibers and ceramic composites. The technology TALOS promised is being deployed just not as one integrated suit. And that's exactly how it should be. Because in combat, reliability beats capability every time. The lesson from TALOS is clear. Soldiers don't need Iron Man suits. They need equipment that works. Lightweight armor that stops bullets. Vision systems that see through darkness. Exoskeletons that reduce fatigue. communications that never fail, weapons integrated with targeting systems, each component developed independently, tested rigorously, issued when ready, not waiting for some mythical, complete system that integrates everything but works for nothing. Current soldiers are better equipped than the TALOS vision. An operator wearing lightweight polyethylene plates, ENVG-B goggles, unpowered exoskeleton, cooling vest, and integrated communications has every capability TALOS promise minus the power problems, weight issues, and integration failures. Future development focuses on improving individual systems. Better batteries for powered exoskeletons when missions require them. Lighter ceramic composites that protect against more threats. Artificial intelligence-enhanced targeting that reduces operator workload. Augmented reality displays that integrate seamlessly with existing equipment. The hyper-enabled operator concept replaced TALOS, focusing on incremental capability improvements rather than revolutionary complete systems. Small, continuous upgrades that enhance performance without introducing catastrophic failure points. This approach works because combat doesn't wait for perfect technology. Soldiers need gear that functions in mud, heat, cold, rain, dust, and chaos. Gear that operates when batteries die, when electronics fail, when everything goes wrong. Simple, reliable, modular systems win wars. Complex, integrated, dependent systems get people killed. The armor that turns humans into walking weapons exists. It's just not one suit. It's the culmination of decades of development, testing, failure, and iteration. It's ceramic plates that weigh less than lunch but stop armor-piercing rounds. It's thermal vision that sees through walls. It's exoskeletons that let you march farther, faster, longer. It's the realization that sometimes the best way to build a superhero isn't creating one perfect suit. It's giving soldiers the tools to become superheroes themselves. TALOS failed. But everything it tried to accomplish is happening anyway. Just smarter, simpler, better.